The geologic timescale is like a timeline of Earth's history, marking major events that shaped our planet and the life on it. From the earliest beginnings billions of years ago to the present day, it helps us understand how Earth has changed. But what about its future? I'm Glyris Dawa, and in this video, we'll take a closer look at the geologic timescale and explore what my team and I predict might happen to our planet in the years to come. Firstly, the geologic timescale is a system used by scientists, paleontologists, geologists, and other professionals to measure Earth's history accurately. It organizes Earth's 4.6 billion year journey into distinct units and subunits, highlighting major events and changes that shape the planet's development. These events include relevant shifts such as continent formation and mass extinctions, which have had lasting impacts on both geology and biology. The timescale is divided into hierarchical units, with each representing significant changes in Earth's history. These units, listed below, provide a structured way to study our planet's timeline. Now, beyond understanding the past, the geologic timescale is also a powerful tool for predicting the Earth's future. By studying patterns such as tectonic activity, geologists can formulate theories and develop strategies to mitigate potential risks. Before we came up with our theory and models, we did our research to ensure that our prediction will be factual. To start, the movement of Earth's continents, first explained by Alfred Wegener's continental drift theory, shows that land masses were once part of the supercontinent Pangaea before drifting apart. Additionally, continents and islands continue to move at an average rate of 1.5 centimeters or 0.6 inch per year, proving the dynamic nature of Earth's lithosphere. Meanwhile, islands face threats like sinking and shrinking due to natural disasters, climate change, and human activities. Rising sea levels, coastal erosion, and the melting of ice sheets, such as those in Antarctica, drive this issue, putting islands like Tangier Island in Virginia and Bilang-Bilangan Island in Bohol at risk of disappearing. Lastly, looking ahead, the concept of Pangaea Ultima envisions a future supercontinent forming 250 million years from now as Earth's land masses gradually merge again. This continuous reshaping of Earth's surface emphasizes the planet's dynamic systems and highlights the need for immediate action to address environmental degradation and mitigate potential future risks. With that, my team came up with the continental reformation theory and designed 5 models for our prediction of the future of the Earth. The following illustrations are based on the research presented earlier to ensure factual and potentially accurate predictions. And the interval in years also begins from 1,000 years to 1,000,000,000,000 years later in the 5 models. For the first model, we personally designed and predicted that the Earth would still be similar to the current one. There was only minimal movement of the land masses, approximately 6,000 inches or 0.1524 kilometers, making it unnoticeable from an aerial view. Furthermore, the animals and known landforms such as mountains, valleys, and deserts are still somewhat thriving in the respective continents where they are found. We also took into consideration the continuous harmful human activities that drive climate change. Thus, the model shows the melting of Antarctica causing sea levels to rise. In the second model, we personally designed and predicted that the land masses would move toward and away from each other depending on their direction. The computed value for the total movement in this timeline is approximately 600,000 inches or 15.24 kilometers. In addition, the model shows fewer land masses and islands compared to the first one to illustrate how rising sea levels and continuous coastal erosion accelerated by climate change affected the Earth. Despite this, the continents that are still thriving are able to sustain their ecosystem with some setbacks experienced, such as global warming that leads to heightened temperatures, even in areas that are located far from the equator. For instance, the model demonstrated the uninterrupted and rapid melting of Antarctica. In the third model, we personally designed and predicted that the land masses are closer to each other compared to the last one. Some continents are already touching, enabling them to travel by land from continent to continent. Moreover, the computed value for the total movement of land masses in this timeline is approximately 600 million inches or 15,240 kilometers. As illustrated above, more countries continue to sink, including the Philippines, brought by the non-stop rise of sea levels and coastal erosion. The ecosystem is also severely affected, with several species going extinct caused by a loss of habitat due to sinking islands. Additionally, climate change is more severe, making weather patterns unpredictable and speeding up the already rapid melting of Antarctica. In the fourth model, we personally designed and predicted that almost all the land masses sunk due to the uncontrollable rise of sea levels as Antarctica fully melted. It also predicts that an extinction may happen in this timeline due to the condition of the Earth wherein its entirety is almost submerged in water. However, because of the lack of human activities, the intensity of climate change may either slow down or become stationary. Despite this, it may take centuries or even longer for the Earth to recover and become a habitable place for both land and marine life again. The balance in biodiversity may take a long time to be experienced. And lastly, the computed landmass for this model is approximately 60 billion inches or 1,524,000 kilometers. With these considerations, our team aims to present a realistic model of the Earth 100 billion years from now. In the fifth and last model, we personally designed and predicted that another supercontinent would rise due to the continuous plate movement and collision in different boundaries. This prediction is based on the theory of Pangaea Ultima by Christopher CORTEZ. Through the continuously changing and rearranging surface of the Earth due to plate tectonics, a new landmass could arise. This will be the stepping stone for another ecosystem, biodiversity, climate, and distribution of life across the planet. It may also form new oceans, mountain ranges, and even coastlines. Thus, for us, this marks a new beginning for another geological era. We also do not close the possibility of another continental drift wherein the supercontinent will separate into smaller continents. Simply a cycle of rearranging land masses that shape the Earth. In conclusion, our predictions about Earth's future through 5 distinct models reveal the dynamic nature of the planet's continents and climate. From minimal landmass movement to the potential rise of a supercontinent, these models highlight the ongoing processes of continental drift, climate change, and the sinking of islands due to rising sea levels. While challenges like ecosystem loss and extreme weather patterns are likely to intensify, these changes also present opportunities for a new geological era. Understanding these processes helps us appreciate the Earth's continuous evolution and the need for proactive, preventive, and reactive measures to ensure its future sustainability. Once again, this has been Glyris Dawa. Thank you so much for watching this video.